Okay, in this last section for chapter 8, we're going to be looking at two different types of quadratic inequalities. So this, I just want you to be open from the very beginning to knowing that the two types of inequalities that we're going to be seeing are very easily mixed up. People have a hard time knowing which one is which, and I'm going to show you it's actually a very easy distinction between the two of them. So the quadratic inequalities that we're going to be graphing, I want you to look and show, so when you're graphing them like in a coordinate plane with x's and y values, note that these ones, when I tell you to graph them, they have y's, they have x's, y's, x's, whereas the ones that you're supposed to be solving, there are no y's, there are just x's. And then the directions are different too. You're either asked to graph or you're asked to solve. So these ones that we're going to be graphing, let me start you off a little step by step so we know exactly what we're supposed to be doing with these. So graphing, first step is to graph the related function. Okay, so you graph just the parabola part of it, almost ignoring the fact that it's an inequality. Okay, so also important to note, is it going to be solid or is it going to be dashed? So before you actually graph it, make sure you're paying attention to that little detail. And remember, that has to do with whether you just have a greater than or less than, or if you have the or equal to on it as well. Okay, step 2, test a point that is not on the parabola. Okay, so test a point that is off the parabola. It should not be a point that's actually part of the parabola. So like 0, 0 is great, but if for some reason 0, 0 is a point on the parabola, then it's not going to work. And last, shade accordingly. So that's really the new part, is the shading part. So you do a test value, figure out if it's true or false, and then you can shade according to whether it was true or whether it was false. Okay, so first one. We're going to plot these the same way that we've been graphing parabolas this entire time. Okay, so we're going to start with axis of symmetry, vertex, y-intercept. We're going to add one little detail. We're going to add x-intercepts, just so that'll prepare us for the next type when we're solving quadratic inequalities. Okay, so we're going to have axis of symmetry, vertex, y-intercepts, and now we're going to add in x-intercepts. All right, so axis of symmetry. We follow our formula, negative b over 2a. So negative 3, and then over 2 times 1. So our axis of symmetry is 1.5. So let's start with that. So 1, 2, so 1.5. It's halfway in between like that. Vertex, we're going to plug the 1.5 in. So plug it into this part right here. So 1.5 squared minus 3 times 1.5, and then plus 2. So that could just be plugged right into a calculator if you want to. So I'm going to show you what that would look like. I should have my phone. So you can do 1.5 squared. Oops, that was a square root. 1.5 squared, let's try that. And then minus 3 times 1.5, this, and then plus 2. All right, so that would give you a negative 0.25. Okay, so if we say this is negative 1, just estimating, negative 0.25 would be like right there, you know, just barely below the x-axis. Okay, next, y-intercept is always just the constant. So if you plug in 0 for x, then 0, 0 plus 2, that would be your y-intercept. So right there. And then we always finish our little shape by doing a mirror image. So if this is 1.5 units over, we go another 1.5 units over and then plot the mirror image. And then before we graph, just for perfect accuracy's sake, we're going to do our x-intercepts as well. So remember, x-intercepts come by setting 0 for y. And then we're going to attempt to solve by factoring, see if we can. So this we start with x times x. And then we want to see if we can multiply to 2 and add to negative 3. And that would be minus 2 minus 1. So if we solve these, if we set x minus 2 equal to 0, we get x equals 2. And if we set x minus 1 equal to 0, we get x equals 1. So this says we have an x-intercept at 2, and then another one at 1. So now we can be totally accurate. All right, so that's the points. Remember, when we're actually graphing, we want to be very careful to see whether it's going to be solid or dashed. It is going to be dashed because I just have the greater than. Okay, so it'll look like that. And last thing we're going to do is do a test point. So pick something off the parabola. So 0, 0 is off the parabola. So let's test, is 0 greater than 0 minus 0 plus 2? So is 0 greater than 2? No, it is not. So that means that 0, 0 will not be part of the shaded region. So our last step is to shade accordingly. So since this is false, this is the part that's not shaded, which means this is the part that is. Okay, let's do another one of those. Same strategy. So we've got axis of symmetry, vertex, y and x intercepts. Okay, so axis of symmetry. We've got x equals negative b, which is 3, and then over 2 times a. So 2 times negative 2 is negative 4. So our x-intercept is 0.75, or 3/4. Start with that. So if this is 1, then we are just doing our best to estimate where the 3/4 would be. It should be like right there. Vertex means we're plugging the 3/4 in. So negative 2 times 3/4 squared plus 3 times 3/4 and then plus 5. So once again, I'm just going to plug this straight into the calculator. So 3/4 squared and then times negative 2 and then plus 3 times 3/4 and plus 5. So 6.125. So that means on this line, we want an x value of 6.125. So there's 6, so 6.125 would be just above it, just like that. Okay, y-intercept is 5, just the constant. So if I plugged in 0 for x, I would get 5 for y. So that would be right there. And we can mirror image it. So be careful with this. This is 3/4. So if I go over, I'd be at 1.5. So 1.5, plot my mirror image point. And for x-intercepts, all right, so this is not going to be something that's factorable. All right, so be careful, because this is definitely a little bit tricky. We are going to do the quadratic formula. So I'm going to do, setting this equal to 0. So I'm going to do the quadratic formula. So x equals negative b plus or minus square root of b squared, so 3 squared is 9, minus 4 times a times c, and then all over 2a, so 2 times negative 2. All right, so let's clean this up a little bit. So negative 4 times negative 2, that is 8, times 5 is 40. So this would have been factorable. So 9 plus 40 would be the square root of 49. So this does come out evenly, which means we could have factored it if we wanted to. It looks like it was going to be tricky anyway. So negative 3 plus or minus square root of 49 is 7 over negative 4. So negative 3 plus 7 is 4, divided by negative 4 is negative 1. And negative 3 minus 7 is negative 10. Negative 10 over negative 4 is 5/2, if I reduce that down. So x-intercepts happen at negative 1, which is right here, and then 5/2, that's 2.5. So right about there. All right, so let's connect the dots. Again, this one does not have the or equal to, so this one is going to be dashed again. Like that. And 0, 0 is a perfect point. It's not on the parabola. So let's test it. Is 0 less than 0 plus 0 plus 5? Yes, it is. 0 is less than 5, which means 0, 0 is part of the shaded region. So that means that's the region that we shade. Okay, so that's the graphing quadratic inequalities. So again, the thing you're looking for is if there's a y like that, then it's going to be graphed in that two-dimensional coordinate system, just like we're used to. Only difference between graphing here and graphing in like 4-1 is that these will have perhaps a dashed line, and there's going to be some shading. The only time you will ever be shading is if you have an inequality. equations are never ever shaded. Inequalities end up being shaded. Okay, solving quadratic inequalities. We're going to solve these inequalities algebraically. So this means we're not graphing, but we are going to be solving these algebraically. So it's going to be really similar to factoring. Okay, so I will walk you through how to do this. So we want to find the x-intercepts. Okay, and the way we do that, first we're going to solve by factoring. We can't solve by factoring with a 2 on that side like that. So we're going to start by subtracting that 2. Okay, so we want to know when this expression comes out negative, less than or equal to 0. So we could plug in different values of x into this expression. So like, let's say for instance I plugged in 0. 0 plus 0, negative 2. Negative 2 is less than or equal to 0. Oops. So that means that 0 would be a solution. That would take way too long, like plugging in a ton of different values. So we have a strategy that's going to figure out exactly what x values I could plug in that would make this inequality true. So that's what I'm trying to figure out. There are plenty of x values that would make this inequality false, and so that means they wouldn't be part of the solution set. Okay, so we're going to start by factoring. We're going to factor these down first. So start with parentheses, parentheses. So x times x gives us x squared. And then I want to multiply to a negative 2 and add to positive 1. So multiplying by a negative, first of all, multiplying to a negative, means I have one negative, one positive. And so to multiply to negative 2 and add to positive 1, that would be a negative 1 times a positive 2. So that's how this factors down. All right, so here's the part that's a little bit tricky. We want to find our x-intercepts. So the x-intercepts of this graph. Remember, if I set these equal to 0, I get my x-intercepts. So setting x minus 1 equal to 0, I end up with x equals 1. And then setting x plus 2 equal to 0, I end up with x equals negative 2. Okay, so I find my x-intercepts first. So that's where this would come out exactly equal to 0. The trick is finding out when it comes out less than 0. So here's what we do. We're going to set up a number line. All right, so set up a number line. And we're going to divide that number line into segments. And we're going to use these numbers to divide it up. So numerically, first I'd hit the negative 2. And then the positive 1. Make sure they're in numerical order, otherwise it'll throw everything off. Okay, so I'm going to mark these on here. And then what we just did is we just split our number line into 3 different regions. There are numbers less than negative 2, numbers between negative 2 and positive 1, and then numbers that are bigger than 1. And we're going to test out something in each of those different regions to see if this comes out true or false. Okay, so keep in mind, this is a product. This number times this number, and we want the product to come out negative. So the way to make a product come out negative is to make sure that one of these is negative and one of them is positive. So we're going to try to figure out what values of x would make one of these expressions negative and one of them positive. So we're going to do that with different test values. So 3 different test values. So here, we want something that's less than negative 2, and you can pick literally anything you want. So let's say like negative 10. Perhaps. So negative 10 is something that would fall in that region. So what we're doing is we're going to test negative 10 in here just to see if it's true or false. So I'm going to plug in negative 10. So negative 10 squared plus negative 10, we want to know if that is less than or equal to 2. Okay, so true or false. So 100 minus 10. Is that less than 2? No, it is definitely not. So this is false. So if I plug something in here, my inequality ended up being false. Okay, so now let's plug in something in between negative 2 and positive 1. So 0 is always a great choice. Whenever 0 is available to you, I would use it. So plug it in. 0 squared plus 0, is that less than or equal to 2? 0 is less than 2, yes, that is true. So if I plug in something in the middle, that's true. So now negative 10 and 0 just happen to be random numbers that I selected. I could have used negative 1, I could have used positive 0.8, anything in there would have worked. I just chose one random value to test. Okay, third region, something bigger than 1. You can use 1,000 if you want. You can use 2, or whatever you want. Let's use 3. Okay, so test it. Is 3 squared plus 3, is that less than or equal to 2? 9 plus 3 is 12. 12 is not less than 2. So that's false. So this region is false. So the region that we care about is the region that comes out true. So that would be this region right here. Okay, so since it's in between 2 points, remember from previous chapters we write that as a three-piece inequality. So it's in between -2 and +1. I start without the or equal to's, then look back at the original. Because the original has the or equal to's, I add them to my final answer. And that would be it. So if I plug in an x value in this range, that'll make this inequality true. If I plug anything outside that range, it'll make the inequality false. Let's look at one more, very similar. I already have 0 on one side. I'm going to start by factoring. So I know it's x times x because this is just an x squared. I want to multiply to 30 and add to 11. So that would be +6 and +5. 6 times 5 is 30. 6 plus 5 is 11. Okay, so now I find my x-intercepts. My x-intercepts would be if I set each of these equal to 0 and solved. So if I set x plus 6 equal to 0, I would get -6. And if I set x plus 5 equal to 0, I would get -5. Okay, so set up your number line. Make sure that number line is in numerical order. So you would hit -6 before you'd hit -5. And now we're going to do some test values. Okay, so test out whatever you want. So anything you want that's less than -6. Let's test -100. Okay, so plug it in. So -100 squared plus 11 times -100 and then plus 30. We want to know if that comes out to be greater than or equal to 0. Okay, so this would be 10,000. Let's see, so 10,000 and then minus 1,100 plus 30. Is that greater than 0? Is that positive? Yes, it is. This is so big that this would definitely come out positive. So this is true. Let's now test. Really, our only option has to be a decimal because these two whole numbers are consecutive. So let's test -5.5. Okay, so if I plug that in, so if I plug in -5.5 squared, -5.5 squared is 30.25. And then plus 11 times -5.5, that's -60.5, and then plus 30. Okay, so this is cutting it close. When I add these two together, I get 60.25, and this negative number is just barely bigger. So no, this is not going to be less than 0. That will come out false. And finally, something bigger than -5, let's go 0. Always take 0 whenever you can. So if I plug in 0, 0 plus 0 plus 30, is that greater than 0? Yes, 30 is definitely greater than 0. Oops. So this comes out true. Okay, so quick note. This is great. This is going to help you get your answer, but that's not your answer. Your answer is the inequalities that you get from these true regions right here. Okay, so this region, all the way off to the left, this is going to be anything smaller than -6. So we write x is anything less than -6. Or when you have two separate pieces like that, you use the word or. And then these are values bigger than -5. So bigger than -5. Now, this does not have the or equal to, so these will not have the or equal to. And that would be your final answer. So if you picked anything inside this range, you would make this inequality true. It's actually very rare that this inequality would be false. There's just this tiny little interval that would make this inequality false.